Hey guys, this is a short chapter, so I'm going to do the video for the chapter all in one shot. So if there's a specific part of it that you need help with, then I will let you know what section we're on in the video. Okay? Pythagorean Theorem. So Pythagoras was a Greek mathematician, I don't know, hundreds, thousands, whatever, years ago. And he and his students discovered that if you took the sides of a right triangle, okay, so I'm going to use some highlighting to demonstrate some things. All right, so this is a right triangle. It has one right angle as one of its angles. And the sides that branch out of that right angle, that form that right angle, they are called legs. So this would be leg A. This would be leg B. Okay, now A and B are interchangeable. It doesn't matter which one I say is A and which one I say is B. Then the diagonal that connects them is called the hypotenuse, and it is represented by the letter C. So we've got an A, a B, and a C, and those are the three sides of the triangle. And what they discovered is that, let me just move this out of the way. Okay, I'm going to blow this one up a little bit. Is if, like, say for example, I have a side of 3 and a side of 4. Okay, the 3 squared, that makes 9. Okay, and 4 squared, that makes 16. And what they noticed is if they add these two together, the squares of those two together, that would equal 9 plus 16 is 25. It equaled the third side also squared. 5 squared is 25. So that doesn't work for any old 3 numbers. Okay, but it works for some combinations of numbers. Okay, so going back to this. So the formula for Pythagorean theorem is a squared plus b squared equals c squared. And you're going to see me color coding a lot to help students sub in the numbers in the right places. Okay, I am using yellow for the legs and another color for the hypotenuse. And we've been doing this right along in class too, is color coding things. Okay? Alright, so that's the Pythagorean theorem. And the first lesson, okay, this problem comes from 9-1, homework 9-1, so if you need help with that, this is one of the problems to look at. We've got 3 numbers, and the question is, do these 3 numbers form a right triangle? Okay, we can take 3 sticks of different lengths and put them together and make an ordinary triangle, but only if we have if we plug in the numbers to Pythagorean theorem and they work, is it a right triangle? Well, here's what I mean. So first of all, take your color highlighter that's not yellow and search out of these 3 numbers which one is the biggest. So 41 is the biggest. Alright, because in a right triangle the hypotenuse, or the C, is the largest number. The other 2 numbers will represent the legs. They're the smaller 2 numbers. Okay, then to start every Pythagorean theorem question, we write the formula. It's like writing a topic sentence in English class for your paragraph or your essay. Okay, it's how you start off the question. And unless the exam that you're taking specifically gives you and tells you Pythagorean theorem, if it doesn't tell you specifically and you just know that you're supposed to use it, you actually get a point for writing the formula. So it's always to your advantage to take 10 seconds and write it. Okay, so the a squared plus b squared equals c squared. We're highlighting in yellow. And the c squared are highlighting in my other color. Okay, since I am proving whether these numbers work or not, I'm going to make a t-chart. Okay, so I'm going to put 9 squared plus 39 squared. Okay, so those are yellow, they go in there. 81 plus, now 39 squared is not something that any of us should be doing in our head. It is not 39 times 2, okay, because 9 squared was 81, so it's not 18. It's 1,521, and then there's a plus sign, so I'll add those together, and I get 1,602. So let's go to the other side where we're going to have the c squared. C was 41, so 41 squared equals 1,681. And just like all the other checks that we've done throughout the school year, if one side has one number and the other side has a different number, that would mean that they are, whatever we're trying to figure out is not true. Okay, so do these numbers form a right triangle? These numbers do not form a right triangle. Okay, so make sure you're writing some sort of short little sentence to say that they do or they do not form the right triangle. Yes or no is not going to be, if you're in my class, writing yes or no on these is not going to be sufficient. That's a pretty generic answer. I want to hear in words that you understand what it means when they're not equal. Okay? Problem 2 asks the same question, but using different words. It says, do these numbers form a Pythagorean triple? It means the same thing as what we just did. So I would take my color highlighter and find the largest number, and then yellow for my other two numbers. Okay? Then a squared plus b squared equals c squared. Okay, and sub in appropriately into a t-chart. So yellow side would be 99 squared plus 20 squared. Now 20 squared is just like 2 times 2 is 4, and then 2 zeros, 20 times 20. But 99 squared is not something I can do in my head. Okay, so 9801 on the calculator. And then add those together. 10,201 on this side. Okay, so now I'll move on to the other side. My hypotenuse, if it is a hypotenuse, is 101 squared. And I get 10,201. So I got each side to match. Okay, you could say this is a right triangle, but you know from English class that you kind of restate the question in your answer. So these numbers are and I'm going to abbreviate here because Pythagorean is a long word, Pythagorean triple. Okay, so that was lesson 9.1. Lesson 9.2 is, let's see, let's go back to pen for a second here. This will be lesson 9.2. Okay, and lesson 9.2 was all about solving for C. So here again, we're going to go to the right angle in the corner to start our highlighting. Highlight out, and then I also highlight the numbers. Go back to the right angle, highlight this side, highlight the numbers. Let's do blue this time. Use a color that's not yellow, and highlight there. Okay, so what are we finding? We are finding the hypotenuse in this question. So again, I will stress, you start with the formula every time. In fact, on your quiz, if you do not write the formula on every question, that's 1 of your points out of 5. So the highest grade you could get tomorrow on your quiz would be an 80 if you don't write the formula every time. Okay? All right, so C is my color. A squared plus B squared is my yellow. So using the color coding, it helps me sub in my numbers where they belong. Now, the hypotenuse, the blue side here, is x. So I will place x, the C with x. Okay, if you leave it C and you don't put the x there, it's totally fine. That's not a problem. Okay, the main problem is subbing in the wrong numbers in the wrong place. All right, 18 squared, not something I know in my head, so I type that into the calculator. And 24 squared is 576, and I will bring down my x squared. Okay. Now, 324 and 576 have a plus sign between them. They are also on the same side of the equal. They are friends, not enemies, so I will add them together. And I make a big deal out of saying that because in the next problem, it'll be different. Okay, so 324 plus 576 is 900. We're almost done. Okay, this says x squared. So the opposite of squaring something is square root. Okay, so x equals 30. So let's just write down the steps that we have here. First of all, formula. Okay, second, we're subbing in. Third, we have to square. I mean, that means apply our little exponent of 2. Our third step is to add our two numbers together. And then finally, square root both sides. And both sides is important to say. Okay, if I put a square root around the 900 because that's the only one I'm typing in the calculator, and I don't put the square root around x squared, believe it or not, even with a correct answer, the state, say on a Regents exam, would deduct a point for that. And if we're only talking about a 2-point question, that's half your points for a really small, tiny detail that didn't even prevent you from getting the right answer. Okay, so it doesn't feel fair, but I don't make up the grading rules from the state. So I like to just point out, these little details to make sure that we get them right. Okay, so that's lesson 9-2. Our next question is from lesson 9-3. And in lesson 9-3, if we get the highlighters out here. Okay, so start at the right angle, go out. You're going to notice that the difference is that this time the variable is one of my legs, and the hypotenuse is now a number that I know. Okay, well, does that make a difference? Well, a little bit. All right, a squared plus b squared equals c squared. So we're still starting with our formula. Okay, for subbing in purposes. Okay, 25, well, that's not a variable anymore. I'll put that in the place of c. Ooh, I did not color code my formula. Okay, and then x and 15 are my legs, and I could put x squared first and then 15 squared, or I could put 15 squared first and then x squared. The order doesn't really matter, although I personally like to put the variable first. Okay, all right, so we did sub in. The next step is going to be to apply the square, the exponent of 2. X squared just comes down, but 15 squared is 225, and 25 squared is 625. Okay, and those are ones I happen to remember because I'm a math nerd like that. Now here's where the problem gets different. Okay, 225 and 625. This is the part on the previous problem where we added together. However, 225 and 625 don't have a plus sign between them. They have an equal sign in between them. Okay, so this would be just like if I said x plus 7 equals 12. You would tell me you would subtract 7 on both sides to get x equals 5. We're doing the exact same thing. The other way you might think about it is to say, well, 7 and 12, we can't add those together because they are enemies. They are on different sides of the equal sign, different sides of the battle line. All right, and 7 is going to get subtracted. So over here, we're subtracting 225 from both sides. And we got to write it on both sides. Don't get lazy on me. The x squared just comes down to get 400. Okay, so what did we just do? We subtract. And we'll put a little note here, both sides. All right, and lastly, square root. Again, both sides. I'm going to abbreviate that SQRT. Both sides to get x equaling 20. Okay, so those are your 5 main steps. Each step on your quiz is going to be a point for the formula, a point for subbing in, a point for squaring, a point for subtracting, that looks like, okay, a point for square root on both sides, okay? So that's lesson 9.3. All right, lesson 9.4 starts off with, let me just write this at the top here. Okay, so lesson 9.4, we're given some information but no diagram. Okay, let's see. So it says leg 13. Well, we've been coloring in and highlighting our legs in yellow, so let's continue to do that. So this leg is 14, and it says find the hypotenuse. So that means I don't know the hypotenuse. That's going to be what I consider my x. Okay, so a squared plus b squared equals c squared. My yellow is going to be my a squared plus b squared. And my c squared is going to be my other color, whatever that might be. Green this time. So 13 squared and 14 squared, those are my yellows, and I'm trying to find the hypotenuse, so I'll put squared, x squared there. Alright, 13 squared is 169, and 14 squared is 196. Bring down my x squared, and then add 169 and 196, and you get 365. Now when I take the square root of both sides, the square root of 365 is not a very nice decimal. Okay, a lot of our examples so far, we've had nice answers. Okay, this is 19.1049737, and actually that decimal goes on forever because the square root of 365 is not a perfect square. So that gives me a decimal that goes on forever. Calculator just kind of runs out of room and doesn't print, you know, forever digits. So we're going to round to the nearest tenth. The calculator said 19.1049 ... Nearest tenth would mean I'm trying to decide whether I should keep the 1 or go up to a 2. So I look at the 0. The 0 set, and I ignore the 4 and the 9 and everything after it. The 0 tells the 1, stay the same. So x equals 19.1. Okay, and let's see, this says leg, so I'll go to yellow here, leg 24, that's my yellow, And hypotenuse, so that's a color, let's use blue this time, is 25. I'm finding a leg, so that's going to be my x. Okay, subbing in. 25 is blue. 24 is one of my yellows. And then x. I always put x first, just the way I like to do it. Okay? Alright, x squared comes down. 24 squared is 576. And 25 squared is 625. Now, here again, I'm noticing that these are on separate sides of the equal, so this would be a subtraction. And I get x squared equals 49. Square root both sides, and x equals 7. Okay, and then we get into some situations of, real life situations where we're reading a word problem. And my big suggestion is visualize what you see being written on the page, visualize it in your head, and then draw a simple picture of what you see, because a diagram is much easier to do Pythagorean Theorem from than reading words. Okay, so we have a ladder and it's leaning against a wall. So very simple drawing. Here's a wall. The wall doesn't just float out in space, it's got to be on the ground. And there's a ladder leaning up against it. So this is going to represent my ladder. Okay, now I see a right triangle in here. There's the corner of it right there. Alright, and it says that the ladder is 12 feet. So I'm going to go to my diagram and put a 12 next to the ladder. And then it says the distance from the base to the base of the wall, so here's the base of the wall, to the base of the ladder, which is, here's the base of the ladder, says that distance is 4 feet. And it wants to know, well, how high is the wall? Okay, or how high does the ladder reach? So now we'll go back to our color coding. And we have this side with the right angle, and this side coming out of the right angle, and our color, let's use orange, that's 12. So setting up a diagram and drawing it first makes this probably by now a no-brainer for kids to be subbing in. C squared is my color, a squared plus b squared here. Okay, so x squared plus 4 squared equals 12 squared. Subtract 16 both sides. 144 minus 16 is 128. Oh, got a little carried away there. And the square root of 128, it's 11 point something, but I don't remember what it was off the top of my head. And so I'm going to punch in my calculator. Oh yes, 11.3. Okay, most square roots, unless it's a perfect square, they're not something you can do in your head. You have to use a calculator. Alright, last one. Okay, a rectangle. Let me move this up. Give myself a little more room. Okay, a rectangle. Okay, here's a rectangle. And, well, man, why are we doing rectangles? This is a unit about right triangles. Well, hold on. Let's just finish reading the problem here. Okay, a rectangle measures 24 centimeters by 143 centimeters. What is the measure of the diagonal? Okay, so if I draw a diagonal line from one corner to the next, I don't know how long it is, I'll put an X here, but now that I've done that, I can definitely see a right triangle. Okay, I've split it into two different ones, okay, and it doesn't matter which one I use. Okay, and depending on how you set this up, keep in mind that each side is 24 and each top and bottom is 143. So then I will go and color code my diagram. There's my right angle. And my hypotenuse. Okay? Okay, so 24 squared plus 143 squared equals x squared. 24 squared, that's 576. 143 squared, I don't know that one and I don't remember what it is. 20,449. Okay. Add 576. And take the square root both sides. And that's 145. All right. Thanks for watching. See you next time.